All right, so today we are going to write logarithmic models that will model data. And so this first example gives the salary of a pastor based on the size of the church. And so what shape of a graph do you guys think this looks like? If you've connected it all, what shape is that? It's logarithmic. So exponential looks like this, or possibly this. This is the shape of a logarithmic graph. And so in a few minutes, we're going to find the equation for this pastor's salary, depending on the church size. All right, so we have found models before using regression. We've done all different types of regression, but today we're going to be doing logarithmic regression. And so we have this logarithmic pattern where you'll have a number and then plus some type of logarithm. All right, so on example 1, we have different data. This isn't the church salary data. This is just 2 different points, and it tells you that this is a logarithmic function, and then you're given like this basic equation to use for it. And then A is a question that you've probably seen before when we did these types of problems before, also on free response questions that we've done on tests. But it says that given the data, write 2 equations that can be used to find the constants A and B in that expression. So what they want you to do is take the X and put it in for X, and then it should equal the corresponding Y. So our 2 equations are going to be A plus B, natural log of 2 equals 3. And then A plus B, natural log of 5 equals 7. All right, so don't be surprised that on our tests that's coming up, you have a question that just asks you to do that thing. Don't be surprised if on the AP exam you have a question that just asks you to do that thing, depending on different types of functions. This test will definitely be logarithmic functions. All right, and then for B, they want you to find the values of A and B. So what we're going to do is use our calculator and figure out what the natural log of 2 is and figure out what the natural log of 5. Oh, and you guys have calculators. Today, most of the stuff we're going to do is going to be calculator stuff. All right, so natural log is just right beside 4. Right beside 4. All right, so that is what the natural log of 2 is. So what I'm going to do in part B is I'm going to go ahead and just replace natural log of 2 with that number. So that number is the coefficient of B. Now I'm just going to go to a bunch of decimal places. We only want to round once whenever we're doing these types of problems. All right, and then on the second equation, we need to know what the natural log of 5 is. All right, so this is a B. It kind of looks like a 6. All right, and so we're kind of going to go back to some stuff we might have done in Algebra 1. I don't think you did much of this in Algebra 2, but this is a system of equations with 2 variables, A and B, and we can solve it for them as long as you have 2 equations with the same 2 variables. Do you guys remember what we would do with these 2 equations to solve? We want to eliminate either A or B. So if we just subtracted these 2 equations, it would eliminate A. And so what I'm going to do, trying to save us some negative issues, is I'm just going to multiply through by a negative on the top one. And then I'm going to add these 2. So the A's are canceled out, which is good. And then for the B's, their coefficients, we're basically going to subtract them. Now they're already in our calculator, so we don't have to retype all those decimals. What we can just go up and do is choose, so go up and highlight the 1.61, and then subtract the other one from it. So just go up and pick it. And that's a b at the end. And then -3 plus 7 is going to be 4. All right, and then what would we do to solve that for b? Divide, right? We would just take that, we would take 4, and we would divide it by that decimal we just got. All right, and that gives us what b is. Kind of tedious. All right, so that's part of the answer. We wanted to find A and B, so that's B. Now, what I'm going to do, and I recommend that you do this quite a bit on the AP exam, is we're going to store that for B. Uh-oh. Let me double check that it's right. 4.3, yeah. You did 4?
I got 4.365.
Oh, I might have just wrote it wrong. Yeah, that's it. I left out the 6. Just pretend there's 6 there. All right, so we're going to store that for B. So you should have it in the calculator. To store something, you hit this number or this button that's right beside 1. And then I want to call this B, which is alpha, and then apps. So now, anytime I need that decimal, I can just type B, and I don't have to type in a bunch of numbers, and it gets a little tedious. All right, so now I need to go back and I need to find A. And I can use either one of these equations to find A. I'm just going to go ahead and use the top one. So A plus B natural log is equal to 3. So that means that A is 3 minus B natural log of 2. Now I just told my calculator that B is this decimal. So I technically can just type that in exactly like it looks. So 3 minus B natural log of 2. And that should be what A is. All right, so that's not super fun. Whenever there is a situation like this one, where the type of equation is this natural log, there is a shortcut we can do. So I'm going to show you the shortcut. Each time you're asked to do this, you need to just double check to see if you can do the shortcut. But if it is the generic form, I guess, is the natural log, we can do the shortcut, or we just do the logarithmic regression. So if you can find some space. So we're going to do L in regression. All right, so I'm going to show you how to do it with just 2 points, and then we're going to do that pastor salary question also. All right, so do you guys remember the first place we want to go if we want to do a regression equation? Anybody? So we're going to do stat, and then we're going to edit. Now I already have the data from the next question in here. You might have it in yours also. So I need to clear it out. So you just hit up, and then clear, and then enter on each of your lists. All right, so I only have 2 little points to put in, so this shouldn't take too long. All right, and then we're going to go back to stats, and we're going to go over to calc. Now I have the updated calculator. If you have one of the older ones, you're going to have to scroll a little bit longer. But the equation I want to find is number 9, the natural log regression equation. All right, and I'm still going to practice storing my regression equation in Y1 because sometimes you need to and sometimes you don't. I'm just going to go ahead and do it every time. So it's alpha, trace, and then choose number 1. There it is. And unless we mess something up when we did it, we should get the same A and B, and it is the same A and B. So much faster. Okay, let's look at the church data. So the table above gives the data of the graph at the beginning of the notes that we talked about in the first problem, or before we started. So we're going to use the regression capabilities of the calculator to find the logarithmic regression model. And we're going to call it S of P, and we're going to let our independent variable be P, which is the church size, and S is going to be the salary. All right, so same thing we just did, but on a bigger scale. So we're going to go to stat, and we're going to go to edit, and we're going to put all that stuff in. So you guys do that for me, please. All right, hopefully I didn't type something wrong. All right, so we're going to do the same thing we just did. So stat, over to calc, choose number 9, the natural log regression. We definitely want to store this in Y1. So don't forget, it's alpha, trace, number 1, and then calculate it. All right, and then I'm going to use the variables that were given. So I'm going to call this S of P, and I'll put the right numbers in for A and B. All right, and then, you guys good? Okay, the B part of this tells us to use that model from part A to predict or to find the predicted salary in thousands of dollars of a pastor whose church size is 500 people. So what they're asking us to do is find S of 500. But because we stored that in our calculator, there's a really quick way to do it, and just do y1 of 500. All right, so we're going to that same place we've been going to get y1. And we just put 500 in parentheses. It'll plug it in there for us and give us the answer. Now, if it tells you to give the answer in thousands of dollars, I would recommend that you just go ahead and use their decimal, be accurate to 3 places, so you could round or truncate at 3, or you could just keep going to 4, whatever you wanted to do. And then say thousands of dollars. All right, you all good? Okay, let's look at number 3. So the most common and preferred method to measure sound intensity levels is using decibels. The sound intensity level in decibels of a sound with intensity I is modeled by that function, where A and B are constants. All right, so what we know is that the sound intensity of noisy traffic is 1 times 10 to the negative 5 watts per meter squared, and it corresponds to 70 decibels. An loud concert has intensity of 1. I didn't put the units, so it should be watts per meter squared, and it corresponds to 120 decibels. So what they want us to do first is like the very first problem we did. We're going to take this data and we're going to write 2 equations. So it's going to be A plus B log, and then we put in the first intensity in for I, and it should equal the first decibels that we got. All right, and then the next equation, we're going to put in the next intensity they gave us equals the next decibels. Can I do the shortcut on the calculator where I just do the data and do a regression equation? So this one is log base 10, or just common log. We can't do it. I can only do that one with natural log, but this one is going to end up being kind of not too bad, actually. So what we need to do is figure out what log of 1 times 10 to the negative 5 is. Anybody have a guess? 10 to what power gives you 1 times 10 to the negative 5? Close. Wrong way. It's negative 5. So 1 times 10 to the negative 5 is 10 to the negative 5. So it's like 10 to what power gives you 10 to the negative 5? So it's just negative 5. That's okay. We can type it in the calculator also. I just need to refresh your memory on scientific notation in the calculator. So the log that we would use here is the one right beside 7. And you would do 1. And then times 10 raised to the power is this blue EE that's right above the comma. So it is just negative 5. All right, so I'm gonna fix this green one real quick. What about 10 to what power gives you 1? 0. So this one right here is just going to be 0. Which is nice because we already know what A is. So then real quickly I can take that and I can plug it back in for A. And then I can find B. So this is one that you could do without a calculator at all. All right, and then for C, the human eardrum can burst when sounds reach an intensity level of 1 times 10 to the fourth watts per meter squared. According to this model, what is the predicted decibels required to burst a human eardrum? So they just want us to take that equation we found and put in 1 times 10 to the fourth, which is basically just 10 to the fourth. So 120 goes in for A, 10 goes in for B. It's going to be log of 1 times 10 to the fourth. All right. Log of 1 times 10 to the fourth is just going to be 4. And 120 plus 40 is 160 decibels. All right. What questions do you guys have?